So today's lesson on patterns, we have to do a little bit of drawing in your notes. So just try to do the best you can. Basically what we're going to look at is we're going to look at some pictures, and we're going to count the number of sides that are in the picture. Like maybe if it's a square, it's got 4 sides, then, or 4 of something. In this case, some of them have like toothpicks or things like that. And then you see that the next one has maybe 8 toothpicks, and then the next figure might have 11 toothpicks. So then you'd have to see what you think the pattern would be. And we've done some patterning before where it asks you what would be the next like 3 numbers in the sequence. That's kind of what we're looking at today. Except some of the time we're going to be looking at pictures of things. So you're going to have to do a little bit of drawing. So our essential question for this chapter is how patterns are used to solve problems. So sometimes you'll see a problem, like I said, that asks you about, like maybe it's an in and an out machine. So you put a number in and you get another number out, and you have to look and see what is the relationship between those 2 numbers. Do you multiply by something? Do you add to get the next number? So you have to figure out what the pattern is. So sometimes it's what the kind of questions they show you. It's like you have an input and an output. So if you put in 12 and you get out 24, and then on the next run you put in 15 and you get out 30, you can see that they're doubling. Yeah. So then that means if you would put in 50, you'd get out 100 because you would double the numbers. Yeah. So you kind of have to notice what the pattern is. So it's about being really observant of the pattern. So here's your problem of the day, just to get you thinking. Although I've been talking about patterns for a few minutes, this one doesn't really have to do with patterns. So remember, problem of the day sometimes is different. Okay, here's what it says. A perfect number is a whole number that is equal to the sum of its factors except for the number itself. Okay, let's look at that again because that sounds confusing. A perfect number is a whole number that's equal to the sum of its factors except for the number itself. So 6 is an example of a perfect number because its factors are 1, 2, 3, and 6. 1 plus 2 plus 3 equals 6. Okay, so a perfect number is where you take all of its factors. The sum of its factors means you add them up, but you leave out the number itself. So that's why the factors of 6 are 1, 2, 3, and 6. So they left out the 6 and they added up all the factors that were left. 1 plus 2 is 3. That plus another 3 equals 6. So that makes it 6 an example of a perfect number. So they would like you to find another perfect number that's between 20 and 30. So this would be a good way to like guess and check, or you have to kind of start at 20 and work your way up, thinking of what are all the factors of that number. And then don't forget 1 and itself, but you don't count itself, but you have to count the 1. Okay, so you use your paper to start, or your whiteboard. It's going to be a number between 20 and 30 that when you list all of its factors and you add up all of its factors, it equals the number itself. Watch. Let me give you an example. No. An example. Here's an example. Here's where you would start. You'd start at 20. Factors of 20 are 1 times 20, 5 times 4, 10 times 2. Right? Those are all the factors of 20. Now if I take the 20 out, but I add up all of these other numbers, let's see what I get.
22.
You're right. So 10 plus 2 is 12, plus 4 more would make 16, plus 5 would be 21, plus 1 more is 22. So all of those equal 22. So 20 is not a perfect number. So then go on to 21. Find all the factors of 21. Add it up, not counting 21 itself, and see if you get 21. And if you do, it's a perfect number. That's what a perfect number is. So the riddle is that it's a number that's between 20 and 30. So we know it's not 20. I did that one for you.
Is it a trick question and there is one?
No, there is one. There is one. I wouldn't be that mean. There's just one. Okay. What did you come up with?
That's you done this.
Okay.
I got 7 and 3.
It has to be a number between 20 and 30. So you missed that part of the riddle, maybe. Has to be a number that's between 20 and 30. Let's try 24. Factors of 24 are 1 and 24. It's 1 times 24. Also 6 times 4. Also 8 times 3. And 12 times 2. If we mark out 24, because it says you don't add the number itself. Let's see. 1 plus, let's see, 6 and 4 here, this makes 10.
8 and 2.
Plus 12 would make 22. Plus this 2 would make 24. So already it's too much. So it's not 24. I already told you it wasn't 23. 22 would be too small because the only numbers you multiply would be 1 times 22 and 11 times 2. So your number is only going to be like, what's that? 14? Too small. Let's try 27. 27 would be 27 times 1, 9 times 3.
That's it.
So if we take out the 27 and we add that up, not enough. What about 28?
29 people.
1 times 28, 2 times 14, 7 times 4. Take out the 28. 14 plus 7 would be 21. Plus 4 more would be 25. Plus 2 more is 27. Plus 1 more is 28.
Yep, 29.
So it looks like 28. It's 28.
Oh, we got that answer. We just added wrong.
Yeah, we just added it.
Okay. So it couldn't be 29 because 29 is another prime number, which wouldn't work.
17.
So 28 is the answer to that. That was a tricky one.
We literally, we were too stressed out.
Okay, your notes, please. Look over at your notes.
We did all this in our notes, and now our notes are,
Cool.
not full.
That's okay. That's okay. So remember I told you we're going to be doing a little bit of drawing here. After we write 2 vocabulary terms. I hear a lot of talking. We're taking a test here soon on this stuff, and you have to know how to do these patterns. So I need you to have your full attention. If where you're sitting, you cannot give me your full attention, I need you to move and sit somewhere else where you can, because there's way too much talking. Some of these groups with these girls here that are big groups is where all the talking's coming from. So find another place to sit if you can't listen from where you are. There's lots of floor space over here too. Here's 2 words. One word is sequence. So I need you to write this word in your notes. A sequence is a list of numbers that follows a pattern. So what we've seen before, which I told you we've seen patterns before, if you see something like 3, 7, 11, 15, blank, 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 they might ask you, find the next 3 numbers in the pattern. So you would have to see between these numbers, it looks like they're adding 4 each time, because 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, and so then that way you could figure out if you add 4 to 15, you'd get 19, and then if you added 4 to 19, you get 23, then if you added 4 to 23, you get 27. So that would be the next 3 numbers in the pattern would be 19, 23, and 27, because we add 4 each time. So a term is the number, each number that's in the list. So when we're talking about the sequence that I wrote here, the 3 is a term, the 7 is a term, the 11 is a term, the 15 is a term, and then I'll change the color here to show you the difference. And then since we're adding 4, I see that's what the pattern is, then my next numbers would be 19, 23, and 27. So those are each called terms. So each number that's in a sequence is called a term. Okay, so we're going to use those two vocabulary words as we go through the rest of this lesson today. So I want to make sure you know what it means.
By the way,
Yes.
you have to be really careful if you're doing, if it's like a long list of these, because if you write a number as the wrong number, you're going to get the whole rest
Yeah.
of them after.
Right. So if you have a whole bunch of terms in a sequence and you have to fill in way over here and you write the wrong one, like say I wrote 22 by accident, then all the rest of my numbers would be off by 1, 2.
26, 30.
Right. That is true. So pay really close attention. Go ahead and sharpen your pencil, Bryson. Okay, so we're going to draw a picture. These are, in the book, they look like little toothpicks that have been used to create some shapes. So I know we're merging kind of two lessons together here. So if I show you that figure number, here's figure number 1. So instead of numbers like terms in a sequence, I'm going to show you pictures in a sequence. So those pictures in a sequence, you should be able to figure out what the next figure would look like. So if I have one that looks like this, that uses 3 toothpicks. Figure 2 looks like this. So draw that. I'm purposely not attaching the lines so that you could see exactly how many lines it took to make it up. And then figure number 3 looks like this. I did. You're right, I did. I'm borrowing it from the pages right there. So there's figure number 3. So if I go through and count, even though sometimes they'll give you a picture, so even on your test, you might see something like this. Please don't do that. Please don't do that. No, that was a purposeful type of noise, just to get people's attention. Okay, so sometimes they're going to show you pictures like these ones and ask you what would figure number 4 look like. Sometimes they're just going to give you numbers, like the terms in a sequence, like what I just showed you, the other example that I showed you. So you might see it either way, but you're really doing the same thing. So here I have 3 toothpicks that made up this shape, 1, 2, 3. The next one I have 1, 2, 3, 4, 5. This one I have 1, 2, 3, 4, 5, 6, 7. So do you see what the next term in the sequence might be? What is the pattern? Karnpreet, what's the pattern?
2.
Add 2. So what would be the next number in the sequence? Yes.
It would be 9.
It would be 9. So 9 would be the next term in the sequence. So it looks like figure number 4, if they asked you to draw it, it would look like the same as figure number 3, except you would have 2 more, which would probably look like that to finish up the square.
Would it have to be that shape though? Or
Not necessarily. Not necessarily. I guess it could look different, but it looks like that looks like where they're going is creating more shapes. So sometimes I just wanted to show you this part, even though this is not in our assignment today. This was in yesterday's that we skipped, so we're kind of merging 2 things into one. I just wanted you to see that sometimes you're going to see, sometimes you'll notice parts where you have pictures like this one, and you have to look at what the pattern looks like and figure out what the next sequence would be, or the next term in the sequence. And sometimes they're just going to give you a list of terms, and you have to figure out what the next term in the sequence would be. Okay, so let's look at an example of if you just have some numbers. Okay, and then we're going to start, then I'm going to let you start on your work today, because we've done patterns before. Look at this one. This says that we're going to draw lines to match the sequence with the correct rule, then draw the line to match the rule with the next 3 terms in the sequence. Don't write all of this down yet. We're going to go through and match them, and then I want you to write what we match just next to each other, just so you can see. Watch, I'll show you. So, for example, we have 5, 14, 23, 32.
Add 9.
Hold on. Now we're going to look here. 5, now, I like how you guys said add 9, right? And you guys agree? Add 9?
Yeah.
The thing is sometimes with a sequence, you look at just the first 2 numbers and you go, oh, you add 9. Although I think you're right this time. Sometimes it looks like you just double the number, but in reality, it's like you double the number and add 1 or something like that. So you have to make sure it works with every term in the sequence. So because you guys said add 9, we're going to check it all the way through the sequence and make sure that's what you do the whole way through. 5 plus 9 is 14. 14 plus 9 is 23. 23 plus 9 is 32. So it looks like it is add 9. So in your notes, I want you to write this sequence, 5, 14, 23, 32. And then next to it or underneath it or something, write the rule is add 9. That way, this is what's going to be in your, this should be what's in your notes. And then we have to figure out what would be the next 3 terms in the sequence. Now, because it's kind of multiple choice, I know it's not going to be this number because that's even smaller than the last number I ended with. See, so some of these you could rule out already. But what would be the next term, Nolan?
41.
It would start with 41. 41 and then 50 and then 59. That's where you would add.
And the trick for it is, another thing is that you can go like, if you do 5, okay, you see 14, if you add 1 and a 4 equals to 5. And it always ends out to be 5. Even with 59, it ends out to be 14, which ends out to be 5. You see, if you add up all the digits until they're a 1-digit number, they'll always be the number you started with.
That doesn't work with every pattern though.
I know. I'm
Okay.
saying if it's not.
Okay, if the pattern is add 9. So this pattern was add 9, so it had a weird rule there. But don't be confused because that doesn't work every time.
Not
Okay,
every pattern,
all right.
just 9.
Okay, so let's look at the next pattern. This one's a little bit harder. So make sure you have this in your notes. Just kind of follow the line and write that into your notes. So these numbers, 5, 14, 23, 32, the rule is add 9 because you're going to have to figure out what the rule is. This one, they gave us a bunch to pick from, but they're not always going to do that. So you have to sometimes just look at it and be able to figure it out. And then the next 3 terms would be 41, 50, 59. Okay, what about this one? 448, 224, 112, 56. What do you think it is?
Divide by 2.
Guys, do you see that? Divide by 2. So this number in half is that number, because if I half a 4, you get 2. Half a 4, you get 2. Half an 8, you get 4. So that's how I get 224. Sometimes it's going to take some guess and check, right? Sometimes it's going to take looking at it and going, I don't know, what am I doing here? And remember, it has to work with every term in the sequence. So this one would be divide by 2. And if I divide 56 by 2, sometimes you have to go over here and do a little problem on the side because you may not get multiple choices to pick from like they gave you here. So 2 goes into 5 twice. That equals 4. So it looks like if you divide 56 in half, you get 28. So it looks like it would be this one. And then I know that half of 28 is 14. And then half of 14 is 7. So it's that one. Okay, let's add one more to the notes. Let's look at this one.
So we're not writing that one in our notes?
You could write that one in your notes. Now you need a number 1 and 2, and we're going to go down here. Skip down to this one. 2, 6, 18, 54. So what rule do you see on this one? Somebody who hasn't answered. Anybody who hasn't answered yet know what this one would be? What would be the rule on this one? Tristan.
It would be
Multiply by 3 because 2 times 3 is 6. Then 6 times 3 is 18. 18 times 3 is 54. So our rule is multiply by 3. And 54 times 3, again, see how I might have to do a little problem on the side because you're not always going to know. But it's 162, which would then be this one. As I said, we got lucky here because this was for your notes. So they actually gave you a bunch of choices to pick from. On your assignment, it's just going to say what are the next 3 terms in the sequence or something, and you'll have to figure it out for yourself. Just like Nolan said earlier, if you get the first one wrong, every one after is going to be wrong too. So when you're doing the sequence, let's say on accident I put 164. Then I multiplied that by 3. Then I multiplied that by 3. Now all 3 of my terms are wrong in my sequence. So if you get one wrong, you'll probably be getting all the rest.
The last one would only be off by 6,
Yes.
but still,
Yes.
it's not right.
If it wouldn't be the right number, so you got to make sure you pay really close attention when you're figuring them out. Okay, let's look at the example in your book. This is one where they've given you a chart to look at, so not a picture and not just a list of terms in a sequence, but this time they've given you a chart. So it says, Mary and her friends find a 4-leaf clover during lunch. A 4-leaf clover has 4 leaves. The table shows the total number of leaves for several 4-leaf clovers. Extend the pattern to find the next 3 terms. So, one 4-leaf clover, I'm looking at the chart here. One 4-leaf clover has 4 leaves. 2 4-leaf clovers has 8 leaves. 3 has 12 leaves. 4 has 16 leaves. What is the pattern of these numbers?
5, 4. And it says, isn't it weird how it says a 4-leaf clover has 4 leaves?
Well, they want to make sure they want to make sure they tell us that it has 4 leaves.
Well, can't
So
you count?
you can, because it's called a 4-leaf clover, you would assume. But we want to make sure everybody knows. So a 4-leaf clover has 4 leaves, so we're multiplying by 4 each time. So that means that the next term, we're adding 4, sorry, not multiplying by 4. We're adding 4 each time because we're adding an extra 4-leaf clover. So our next number in the term, we're going to write here, adding a 4. So our next number in the sequence would be what, Angelina? 20. And then if we add 4 to that, what would we get?
24.
24. And then if we add 4 to that, Nolan, what would we get?
28.
28. So the next 3 terms are 20, 24, 28. So this time, the pattern was add 4. Okay, let's look at the next example. Example 2 says, Maria and Zhang are training to run a half marathon. A half marathon is about 13 miles. Their weekly training plans are shown in the table. Use the information to write a sequence to represent each person's weekly training plan. Then compare the plans. So Maria is starting at 2 miles, and she's going to add 2 miles per week for each of the next 4 weeks. So a sequence with 5 terms for Maria's plan will be 2 is what she started with, and then if she adds 2 miles each week, what would be the next week? What would be, how many? What'd you say? 4. And then the next week, how many would she run? Then 10. That's 5. 1, 2, 3, 4, 5, right? They said 5 terms. So 2, 4, 6, 8, 10 would be the first 5 weeks of her training. Now Zhang, he's going to add 4, or he starts at 4, and he adds 4 each week. So he starts with 4, then what would come next? 8. What comes next?
12,
Then?
16,
And then what?
24.
So 4, 8, 12, 16, 20. So if we compare their 2 plans, each week Zhang plans to run twice as many miles as Maria. If you look at each of the weeks here, because he started at double what she started with, and you doubled it, or you added that same number each time, it ended up being that if you look at her training plan compared to his, the relationship between each week, week 1, week 2, week 3, week 4, week 5, he's always running twice as many miles as she's running. So that's what they were asking you to do on that question. Okay, so for the rest of the assignment, you're going to first work on the guided practice, then just check it with someone. Make sure they have the same numbers as you. Remember, sometimes you're going to look at charts, sometimes pictures, sometimes just a sequence of numbers. We're going to do a little bit of a shorter time today because this isn't, it's not going to take you that long. So 20 would be too long. I'm going to do 15. I can as soon as you, make sure you have a question though. I mean, come up with a question, just not like I don't get this or something. Is it divide by by 3? Maybe skip some of the ones that are harder, and I'll try to maybe do that one together on the board because the numbers are bigger. Okay? Guys, listen. If the numbers are getting bigger, common sense says you're either going to be adding or multiplying, right? If the numbers are getting smaller as the sequence goes on, then you're either going to be subtracting or dividing. Right? Make sense? Yes. Numbers get bigger, you're either going to add or multiply. Numbers get smaller, you're either going to be dividing or subtracting. I think I'm going to work out on the board in a couple of minutes. Number 3. I'm going to work number 3 out on the board in a couple of minutes. So if you're stuck on that one, go on to the next one. I just want to show it is, but I want to show everybody how we can get that.
What's the next 3?
So then you would do 54 divided by 3.
That is 17.
And then 7. No.
Yeah.
You sure it's divided by 3 then? Because 17 doesn't get divided by 3. Skip that one. We'll look at it all together in a few. I need to get this. I want to get this saved and then. Could be subtract.